So this is a coil out of an alternator, okay? And you can see how it's wound. You see how it's uniformly wound, but it's kind of loose, okay? This is a Regenex coil.
Nice and tight.
Feel it.
Oh.
Okay.
Yeah.
So if we took this coil, this is, I'm not disclosing any confidential information. If we took this coil and we physically wound it like this, with all the air gaps and everything, this would stop functioning.
Got it.
Okay? So there's a way that you have to make it.
Because it's so loose and that's so tight, and there's...
Yeah, this adds to,
Got it.
yeah.
Got it.
And you can actually read about it in there.
Okay.
Okay, so I'm just... So we're going to show you this prototype. What I'm going to do is I'm going to bring the system up to rotational equilibrium, okay? Which means that the power, the net power in the drive shaft, the net torque in the drive shaft is 0, which means the power in the drive shaft is 0, okay? The prime mover, which is an electric motor, we're going to be monitoring the input power to the prime mover on this here, okay? So when we deliver about 10 watts to this load from the conventional coil, which is red, okay? This number has to go up by a minimum of 10 watts, okay?
Okay.
We're also gonna note the starting point, let's say 150 watts here, okay? At 150 watts to the prime mover, we're at rotational equilibrium, power in the drive shaft is 0 mechanical watts, okay? When we take 10 watts from here, this is gonna go up to like 160, or it has to go up to by at least 10 watts, okay?
Okay.
When we place, and we'll see the load current sine wave on the oscilloscope. When we place the Regenex coil on load, this number is going to go down to a number that's less than what we started at on idle. Okay? Less. So at idle, the power in the drive shaft is 0 watts. Rotational equilibrium. You can't get around that. So when the Regenex generator is delivering power, it's using less power. It's using less than 0 watts of mechanical input power.
Wow.
Okay? If you start at 0 and it goes down, it's negative. Okay? All that means is that if you're starting with half a megawatt at idle of mechanical power, it's going to go down to 400, 300, whatever it is.
Because of the coil.
Because of the way it works.
Got it.
Okay? So this will be reading the voltage across the load, and this is the current. It's going to be about the same amount of current that you experienced there, about 1 amp.
Yeah.
Okay, and it's about 10 volts. So we're dealing with about 10 watts.
Okay.
Okey dokey. So, right now, our system is rotating, is at rotational equilibrium.
Okay.
The prime mover is consuming 202 watts. And we're on no load,
Got it.
okay?
Yep.
So I'm going to connect the conventional coil first. $10 volts. With 1 amp, you can come in. So we're at about 10 watts here, okay? You see how our input's gone up to 21? This is conventional generator operation, okay? Now and we can see the load current sine wave. This is for the conventional coil. Okay, this is
Traditional,
This is
what's going on in
all
the
normal,
market,
yeah.
all in the market.
okay? So now I'm gonna connect the Regenex coil,
Okay.
but I just wanna remind you where we started again. So this is our half a megawatt for a water or for 1 megawatt generator.
Okay.
This is our additional 1 megawatt to generate a megawatt, okay? So now I'm going to put the regenerative acceleration coil online. We started at 206. Now we're down at 199.
Oh my God.
Now, this voltage has gone up.
Saw that.
The current has gone up slightly.
Yeah.
So we're delivering more power now from our conventional coil than we were with just in load. I'll take it off again. So, again, if this was an EV, this would be regenerative braking, okay? The speed of the system, you can actually hear it going up and down.
Yep.
The speed of the system has gone down. Now I'm going to put the regenerative acceleration coil on. So again, we're at 10.3 here, and this is, look at that, that's 10.3 as well. Okay?
Yep.
All right, or 1.3. So regenerative acceleration mode, and again, you'll see the load current sine wave for the conventional coil. And we need less power when we're generating electricity than we do at idle. So this is where I was saying, you
This is
start,
with your
yeah,
oil,
yeah,
as I'm seeing.
yeah,
It just went down.
it goes down,
Yeah.
yeah. Okay, so now I'm gonna put the other regenerative acceleration coil in on load,
Okay.
and you're gonna see something else. The more power that you deliver to the load in conventional generator operation, the more power you have to put in the drive shaft. Regenex coil, the more power you deliver to the load, the less power you have to put in. Okay? So we're at 198.
Covering right there.
Yeah, we're at rotational equilibrium again. And this is the load current sine wave for the Regenex coil.
Green.
Yeah, and it's explained.
And the purple is what it used to be.
The
That's
purple is the conventional coil. They're both operational right now,
Yep.
but this one should be, well, there's a delay, okay? This is 90 degrees.
Yep.
Take my word for it.
Yeah.
It's about 45 to 50 degrees delay, okay? And the loads are,
But I think this is saying it's more efficient.
no, it's just saying that, if you read that document with this analysis on it, you'll get a better picture. But it just means that the load current is delayed. In this, it's the current that creates the resistance, okay? If you delay the resistance in the time domain properly, you can actually get it to provide assistance rather than resistance. I'll explain that to you in a second, but I want to show you the other regen flow, okay? So we started at 199, we're down at 193, 194. This has gone up a little bit, but now the load current sine wave has shifted by 90 degrees. Okay? This doesn't mean a whole lot to you right now, but it means everything to the operation of the innovation coil. Okay?
So by connecting these, what was this? What is that adding more?
Yeah, this is a second regenerative coil now in operation.
Got it.
So it's
So you have two of them.
yes, and it's shifting the load current even more.
Got it.
So I'll take this one off. You'll see the output will go down a little bit when I take it off.
Yeah.
And if I take the regenerative coil off, it'll go down even more. So here's what we're doing. I'm going to explain this quickly to you. The magnet, and you can hear that it's slowing down. The magnetic fields that the regenerative coil is producing, the magnetic field that the conventional coil is producing is slowing down the system. Okay? We've already established that. The magnetic field that the regenerative coil produces is accelerating the system. Okay? But we're also collecting that magnetic field and using it to add more power to the conventional coil. Okay? That's why it goes up. Small thing, but it's important later on. Okay, is this clear? You good?